All right, then, finance friends, let's now jump from our lump sum TVM calculations into our annuity calculations. They're a little bit more complex. There's a little bit more going on, but what you're going to see is that the power that they have is very, very big. The idea that not just a lump sum over time growing, but the commitment to make recurring contributions or recurring cash flow investments can really, really make your financial future. Okay, it's a bit more complicated, so let's go into it. Remember, keep in mind the broad concept, keep in mind the formula, know that we have the table shortcut. Whenever you're confused about how it actually is playing out, get it out of the abstract and timeline it to visualize it, and then we'll do some practice questions, okay? So let's jump into our next topic, and this is the future value of a series. In case I haven't mentioned it the last couple of videos, the time value of money is still probably the most important concept in personal finance. In TVM calculations and annuity, this is a new word. And by the way, when we use annuity in time value of money, it is different from when annuity is used in the context of like an insurance product. So if by chance you've been looking or thinking or reading about insurance, leave that annuity concept aside, focus on this one here in time value of money, okay? An annuity is a series or a stream, we'll call it, a series or a stream of equal cash flow payments that will be received or paid in the future, okay? So with an annuity, we're getting out of the lump sum one time only and into a recurring series or stream of equal ongoing payments that are either made or received sometime in the future, okay? From a technical jargon point of view, there's two types of annuities. There is an ordinary annuity. With an ordinary annuity, the cash flow payments or the investments occur at the end of the period. We're going to be focusing on these primarily, okay? However, there is another type, and that is known as an annuity due. And with an annuity due, those cash flow payments, they occur at the beginning of each period. It's a subtle difference, but you can also imagine that with an annuity due, because you're putting the money in up front, as opposed to at the end of the period, you're going to get an additional period to grow it. And in theory, over time, that can make a pretty important difference in how that money grows. But again, for now, just know that there's two types, ordinary annuity and annuity due. We'll be defaulting to ordinary annuity here. The future value of a series, the future value of a series, AKA the future value of an annuity, AKA, because I stutter a lot and I'm lazy, the FVA, the future value of an annuity is how much a series of regular cash flow payments or investments will grow to, given a particular interest rate and the number of payments made. So you'll see again that we're dealing with the variables of interest rate and number of payments, but here we are talking in the world of FVA about how much a series of regular cash flow payments will grow to. If you didn't need timelines in the previous things, they might be really helpful here, because it's much easier to envision cash flow of a series. You know, let's say that you were going to set aside $1,000 a year for the next 5 years. How is it going to play out? With the lump sum, it was sort of easy, but if you have a timeline, 1, 2, 3, 4, and 5, it can really help you. Because what we're saying is, you know, you're going to be putting $1,000 away at the end of year 1, and another 1,000 at the end of year 2, and another 1,000 at the end of year 3, and 4, and 5. And what you're doing here is you're basically pushing each of the flows forward. You're pushing each of the flows forward. And at the end, the different values are going to add up to your total. Okay? So timelines can be a really good way to visualize this because they can be a little bit confusing. Okay? In terms of solving these problems, you can determine the FVA with a formula. The future value of an annuity, that's the formula, is equal to the payment multiplied by 1 plus the interest rate raised to the n minus 1 divided by the interest rate. It's a big one. A lot going on here. Note again that we're going to have some basic variables. We're going to have the future value of the annuity, which is really what we're solving for. We're going to have the payment. That's the actual amount of the flow or the stream that's recurring over time. We're going to have the interest rate. We're going to have the number of years. Okay? So you're going to get your future value of an annuity is equal to the payment that you're making on the recurring equal basis multiplied by this big thing here, 1 plus the interest rate raised to the exponent minus 1 divided by the interest rate. Okay? Now, clearly, that's a lot to calculate. So shortcuts are handy. And in fact, we have one. We can determine the future values of a series of payments by multiplying the fixed payment amount by what we're going to call the future value interest factor for an annuity. A lot of words, a lot going on. You can get it though. We can determine the end amount by multiplying our fixed payment amount, that's our payment, that's our recurring number, by the future value interest factor for an annuity, or as we abbreviate it, FVIFA, which, as you guessed, you can find in tables. You can search them, they're in the textbook, you know this already. But what it's going to come down to is the future value of the annuity is going to be equal to the payment amount multiplied by the future value interest factor for that annuity given the particular interest rate and time period that you're discussing. And with that shortcut, life becomes much easier. You will notice that these can be used in a variety of ways. One useful application of FVA calculations is to estimate how much money you will have saved by a future point in time if you commit to periodically saving a specific amount every year. So this is one way that these are used. If you can make an estimate of what a nest egg will grow to if you commit to saving a particular amount every year. Again, we use the formula, the future value of your annuity, which would be what you're growing to, because if you're kicking in money every month or year, it's an annuity. It's going to be equal to the payment, which is the amount that you're committing to, multiplied by your future value interest factor for the annuity. So you can take this equation and use it in a couple of different ways. Another way you can do it, you can rearrange that equation. And if you do that, you can use the FVA concept to determine how much you need to save annually in order to accumulate a desired future amount. So again, the formula here told you if you kick in a certain amount, given certain interest rate and time parameters, this is how much it will grow to. But if you rearrange that equation, you can determine how much you have to commit to if you know what your savings target is. So the amount that you would have to kick in, which would be your payment, if you rearrange the equation, will be equal to your FVA divided by your future value interest factor for an annuity given your particular time and interest rate. And that's why those tables are really handy. You can also do some sensitivity analysis, for example, and say, hey, if my timeline increases or decreases, if my rate of return, my interest rate increases or decreases, you can also play with different scenarios, again, to help you plan. Really important. Okay? With that said, let's do some practice. If you guys would like, you're welcome to pause the video, try to work these out. I'm going to run through these solutions for you now. Number one, Carla. Our friend Carla, she commits to depositing $3,200 a year into her retirement account. If the funds grow at 9% per year, look at this baller growing her money big. And she has 40 years to retire. How much will she have? Well, we can do this in a couple ways. Let's first get our variables written out, okay? Our payment, $3,200. Our interest rate, 9. Our N will be 40. Our future value will be, we don't know, but we're going to find. And in case you're using a financial calculator, you would need to indicate that your present value is 0 because she's just starting it now. We can also map this out. I'm going to do it up here to save some room. We can also map this out on a timeline. We could say that, you know, Carla is here at year 0, and she wants to invest every year all the way to years 39 and 40. And she's going to be putting $3,200 away. 3,200, 3,200, all the way out. And what we're looking at here, we also do it her last year, what we're looking at is we're pushing all these flows forward. And we're pushing them forward at 9%. And when we get each of the flows and then we add them all together, that's our answer. So you can visualize it that way. We can also solve it, as we know, with formulas. So let's do it. The FVA is equal to the payment, multiplied by 1 plus the interest rate raised to the n minus 1 over the interest rate, which will be equal to 3,200 multiplied by 1.09 to the 40 minus 1 over 0.09, which will be equal to 3,200 multiplied by 337.882. And Carla is going to be a millionaire. Good for her. You see now how the power of both ongoing commitment and time plays out. $3,200 multiplied by these different factors will give Carla $1,081,223. If you didn't want to go through all this nonsense, you could just go to your tables and you could see another way to solve it. The FVA would be equal to the payment multiplied by the future value interest factor for an annuity at 9% and 40 years would be equal to 3,200 by 337,882. Again, the factor here summarizes all the information here. So it makes a nice, easy shortcut. Multiply that out. The answers will match up. And Carla, sorry about that, and Carla is a millionaire. And there we go, okay? Another example, back to our old friend Danny Boy. He's back. Danny Boy's 30 years old. He wants to know how much he needs to invest every year. So last time he wanted to put a lump sum in. Now he says, I've studied finance. I want this annuity thing. I want my money to grow with the commitment over time. He wants to know how much he needs to invest every year in order to have $100,000 when he turns 60. He can earn 6%. Let's map it out. Let's get our variables down. First things first, Danny Boy wants a future value of $100,000. His N, well, he wants to retire or have the money at age 60. He's 30 now, so 60 minus 30 gives him 30 years to grow it. He's going to have an interest rate of 6%, and we're solving for his payment. Again, if you were using a financial calculator, you would also want to indicate that the present value is 0 because he doesn't have any in it right now, okay? With that said, we can do the formula. The payment is equal to the FVA divided by 1 plus I to the N minus 1 divided by I. Notice that I took our formula and we rearranged it a little bit. Before, with Carla, we said if she puts this much money in, what will it grow to? We can also rearrange that and say, if I want to have that much money, what do I have to kick in? That's what we're doing here for Danny Boy. We would then say that that's equal to 100,000 divided by 1.06 to the 30 minus 1 divided by 0.06. And that's going to give us a value of 1,26489. So if Danny Boy can commit to kicking in that much money every year for 30 years, he will have his 100,000. Okay. I would leave it to you to then say, wow, 1264 a year is not bad, because if you figured out what that equaled by month or by week or even by day, you can see that small commitments over time make all the difference. If you didn't want to do all that nonsense, we could do a shortcut. The payment would be equal to the FVA divided by the FVIFAA. That's the future value interest factor annuity. The table number for 6% 30. That's going to be equal to 100,000 divided by 79.058. And that will give you 1,264.89. There you go. Okay. Final question for you. You have, by the way, I'm trying to trick you on this one. I'm throwing it out there right now for you. You have $80 of each monthly paycheck invested in your retirement account. Good job. You earn 5% annually. What will your account be worth in 30 years? This was a bit of a trick question. And the purpose of this question was to alert you to the fact that when you go from annual to monthly, you have to make some adjustments. You are making your payment monthly. You're earning annually. You want to figure out annually. To do this, we would have to calculate that your payment is equal to 80. That's easy. But your interest rate is equal to 5% divided by 12 equals 0.417%. We had to do that because you cannot multiply the $80 monthly payment by the 5% annual return. You have to equalize your terms. If we're dealing with monthly, our payment is $80 per month. Our interest rate is 5% per year, or 0.417 per month. How about our N? Our N is going to be 30 times 12 equals 360. Again, because we're doing monthly, we have to account for not 12 windows of time, but not 30 windows of time, but 360 windows of time. If you do all of this, and if you were to put it in the formula, you would get an answer of $66,630. Again, the mechanics of the problem are still the same, but I wanted to layer in one extra element. When you move from annual to any other time frame, quarterly, semi-annual, monthly, weekly, whatever it is, the formula still works, but you have to make sure you're talking on equal terms. And that would typically mean adjusting your interest rate and adjusting your N value. If you keep those consistent, you'll still get your correct solutions. Great job, my friends. Keep practicing this, keep thinking about it, and I'll see you in our next video to wrap up TBM. Thank you.